keeping the momentum going and avoiding the post-lunch snooze. Up next, we have a presentation on power system benefits of energy efficiency. It will be conducted by Ms. Shweta Kulkarni. Please join me in welcoming Ms. Shweta Kulkarni, Fellow, Prayas Energy Group. She has over 10 years of experience in energy policy, specializing in energy efficiency, smart metering, and renewable energy. She leads initiatives on electricity supply quality and residential monitoring and serves on key committees with CEA, NITI Ayog, and the Ministry of Power.
But nonetheless, before I begin, I'd like to thank the Gateway, specifically Alka ma'am, Kandat sir, for inviting us here to make this presentation. Also to AAA and CEW, our colleagues, for inviting us to talk about what we have been researching, studying in the aspect of building energy efficiency in Gujarat specifically. So essentially, just quickly, what is Prayas Energy Group or what we do? We've been working in the space of energy policy, regulation, governance for over 30 years now, associated with several central and state governments as well as ministries. There are specific areas that we focus on, most of which are centered around energy. And the idea is to make energy more accessible, affordable for all consumers. So what I'll be talking about today is just a quick recap. I think many of these things, most of the presenters and the panelists have talked about before the lunch in these sessions. But essentially, what is the role of efficiency and demand side management, and why are we even talking about it here? What is the need for better demand estimation, and then coming to system level benefits of energy efficiency and demand side management, specifically for GOVNL moving into 2030. So I think, like I just mentioned, most of us have been talking about the increase of electrification in areas of transportation, industry, heating, cooking. I think even Hari Kumar sir was talking about bringing in more induction cook stoves in Kerala. And this is a movement that we are seeing across all sectors. At the same time, there is a significant increasing share of variable renewable energy, and I think most of people who have come from distribution companies here this would resonate, as where as more and more rooftop solar starts penetrating into the grid, we need to have our grids or make our grids more flexible enough to be able to absorb power from solar and at the same time meet the demand that is coming in. And on the other side, there is a global as well as a national push, and there are policies in terms of in terms of stressing the need for energy transitions to moving away from coal thermal for generation, moving away from fossil fuels. And at the same time, there's a lot of digitization that is happening in this sector, especially owing to smart meters as well. I think Suruchi here will throw more light on that in the sessions ahead. And along with this, what is happening is, as electrification increases, we also understand that there is a need to understand this demand better, where it is going to come from, when it is going to come, and what impacts is it going to have on the distribution as well as transmission grids. So a rigorous demand of historical data itself can tell us a lot more about what can happen in the future. And I think Aman here was talking about some of these numbers, especially in the context of Gujarat, in terms of the trends, what has been happening in the past, etc. Rapid adoption of flexible loads in terms of, let's say, smart air conditioners, electric vehicles with smart capabilities, as well as use of electric water heaters in place of solar water heaters is also something that we need to start keeping in our mind as we proceed further. Another important event that has been happening across multiple states, Maharashtra being the leader for it, which is solar as agriculture. So how much of your agriculture demand can actually shift to daytime and can allow the grids to absorb more solar. Changing weather patterns, I think especially the current summers has been really terrible for all distribution companies as well as consumers alike, where the surges in the heat waves that we saw led to a lot of air conditioning load as well as space cooling load in other sectors also. For the distribution companies, another challenge is of course the sales migration that is already happening, and there is a chance that we see more of this happening. So how does the distribution company really start looking at their demand? And this is also equally important for the load dispatch centers to manage this more effectively. Finally, what is necessary to now understand this demand better is having access to more granular demand data, and especially if we go to about 15-minute granularity. So some of these aspects we have tried to touch upon through the study that we did, some of which are based on assumptions and some based on studies from across the country. So coming to the system level benefits of energy efficiency and DSM. So the objective with which we started this study was to essentially provide benefits or estimate the benefits of demand side management in a high renewable energy system with a stylized example of Gujarat. Now when I say provide evidence is essentially because even this morning we have been talking about demand side management, we have been saying energy efficiency is important, but we also at the same time acknowledge that a lot of distribution companies, regulatory commissions as well as state governments are not investing enough in really taking these efforts ahead. And why is it that this is happening is we believe, we all know yes DSM and energy efficiency has significant potential, but we don't know what that potential actually is and what that potential actually translates to in terms of benefits for the sector in general. And that is something that we tried to quantify through this study. So what we did was for Gujarat specifically, we built a bottom-up estimation for the 2030 scenario, wherein we built in demand side management as well as energy efficiency measures given what the demand would look like in 2030. And then we used a production cost simulation model, which is an open source model which is called GridPath, to estimate the benefits of these demand side management measures that were introduced for Gujarat. And when I said high renewable energy systems, most other states have an RPO of 43% that they have to meet, but Gujarat state policy recommends that Gujarat will achieve about 50% of RE generation in their grid. So how do you basically make the grid more flexible to allow so much penetration of solar energy into the system? So this is a quick snapshot of our study design. It's very simplistic here. I'm not dwelling into a lot of details in terms of numbers, etc. We'll focus more on the results and the benefits that we see. So essentially we developed the model with two demand scenarios. One, which was the electric power survey demand in 2030, provided by the Central Electricity Authority, considered to be the baseline. And then we developed bottom-up demand estimation for 2030, which we have named to be the DSM scenario. For the state of Gujarat, industrial, residential and agricultural demands contribute to most of the share, and hence we focused on these three sectors in the bottom-up estimation. For the bottom-up estimation, we have done two things. Specifically for the agricultural demand, we've done our own assumptions and computations. A lot of this information will be very soon available in the public domain in terms of the computations, analysis, etc. But if anybody of you are interested, you can contact me. I'm happy to share with you all these assumptions. For the industrial demand as well as for the residential demand, we are also taking cues from another energy economy model that we built at Prayas, which is called RUMI here, which allows us to do a very granular bottom-up demand estimation specifically for the residential sector. Both these scenarios have then been input to the GridPath production cost simulation model that we built, and in terms of results, what we get is the supply stack that is required to meet this demand in 2030. So I will just go quickly into the insights and assumptions and what are the benefits that we are seeing. So this is how the residential demand in the two scenarios going into 2030 looks like. So the EPS has projected that the 2030 electricity demand for Gujarat is going to be about 22 BUs, with introduction of demand side management and energy efficiency, specifically in the residential sector, we can reduce this by almost 30%. And when we say reduction, what does it actually mean? So specifically for 3 appliances, which is air conditioners, ceiling fans, and for refrigerators, improvement of overall stock efficiency from what is in current, that is 2022, going on to the DSM scenario in 2030, we assume that the stock efficiency will increase to about 28%. Currently it's around 13 to 14% for air conditioners. Average wattage of fans, which is currently at around 70 watts, will go up to 36 watts, and 25% of the refrigerator stock will be 5-star in 2030. Now, what this essentially means is that this is not just what, let's say, the state of Gujarat needs to do, but we have been talking, let's say, all day long in terms of the policies, in terms of, let's say, standards and labeling. Today in the market, there is no refrigerator with a 5-star efficiency that is available. The most efficient refrigerator that you can get in the market is a 4-star efficient refrigerator. So we need to have policies which will help us to push that efficiency further and achieve the target of 5-star efficiency in refrigerators as well. Moving on, in the industrial demand in 2030, we have worked very specifically in improving the efficiency of motors, and what we see is that going on to 2030, we can, with improvement of efficiency in motors, we can bring in about 7% reduction in their demand. There is no baseline data available on how these motors function and what amount of electricity they are consuming, but based on certain studies at, like I said, at the national as well as in different states, we have used those assumptions. For the agricultural demand in 2030, we see that there is significant potential that can be achieved by energy efficiency, and that's to the tune of almost 39%. The EPS demand for agriculture is, as per our analysis, is significantly higher in 2030. This is also based on the historical trends of how agricultural demand has been growing in the state. With, let's say, minimal interventions in terms of, let's say, 2 lakh pump set replacements per year, and ensuring that all new pump sets will be energy efficient, by 2030 Gujarat can easily achieve over 80% efficiency in their pump sets. We've also done some cost calculations and estimations as to if we have to really roll out such a kind of program, what would it mean, how much subsidy would it save going on to 2030. I have not put out those numbers here. Maybe if anybody of you is interested, we can take this further for discussion. So this is how we built up the bottom-up estimation. This is the final load curve that we developed for 2030. The curve with sectoral representations shows how the demand side management curve looks like. For agricultural demand, both in EPS as well as the DSM scenario, we assume that the entire agricultural demand will be shifted to daytime in a bid to solarize agriculture. So effectively, we see that in 2030, with introduction of energy efficiency, demand side management, and shift of agricultural demand to daytime, we can save about 23 billion units of electricity in 2030. And there is also significant peak demand reduction of around 2000 megawatts. What all of this translates to, before I go to that, I will just quickly talk about the model setup that we used for estimation of the results. So in grid path, like I said, we built 2 scenarios, one being the baseline, which is EPS, and the DSM scenario based on bottom-up estimation. And in terms of generation or the supply stack, we assume that 50% of this share will come from renewable generation. No new thermal capacity will be added, and other than the existing contracts, and there will be no retirements in these plants. Optimal storage capacity has been determined exogenously. There's also scenario development, so can be added, reduced, depending on further discussions also based on how GUVNL perceives capacity addition for storage. And market purchases have been subjected to interstate transmission constraints. At the same time, this is a copper plate model, so there is no transmission sort of modeling that has been done as a part of this effort. So overall system benefits that we see in 2030, given this demand side management, is the total demand reduction is certainly at around 13%. Savings in investment required for new capacity is almost to the tune of 40,000 crores. I have another slide here, I've put it in the backup. Maybe if you're interested, we can look at where these cost savings are coming from. But essentially, the capacity that you have avoided based on the 13% savings that you've done will give us about 40,000 crores of savings. The savings in annual system cost in terms of operation are about 17,000 crores. And there is certainly going to be reduced investments in distribution infrastructure upgradation, which has not been a component of this particular exercise that we've done, but it's certainly significantly signals to that. Savings in variable costs due to reduced coal thermal power purchase will be to the tune of almost 500 crores. And finally, because we are also going to avoid a lot of coal thermal generation, there will be about 8.5 million tons of carbon dioxide that will be saved. So what DSM and energy efficiency is allowing us to do is not just reduce our, let's say, capital expenditure, but at the same time also reduce carbon dioxide emissions and move towards decarbonization. Some other interesting insights that we observed from our study, I'm just sharing very quick snapshots, is we try to also do an exercise by saying if we don't want to shift the entire agricultural demand to, let's say, the daytime and shift only probably 70% of it. So what is the difference? So essentially, if you don't shift the entire demand and shift only 70%, curtailment with, let's say, entire agricultural demand shifting to daytime, curtailment of solar would reduce by almost 20%. So more solar ingress is certain with shifting of agricultural demand to the daytime. Another small exercise that we also did is, this is a heat map, and it is showing you the months and also the hours of the day when high cost power is being purchased. When I say high cost, this is all power above 8 rupees per unit. So with implementation of demand side response programs in, let's say, about 2 hours in the morning and about 2 to 3 hours in the evening, the utilities could certainly save about 200 crores and 270, so together about 470 crores by shifting this demand to the daytime, which essentially means avoiding purchase of high cost electricity in these peak hours. And interestingly, in both these scenarios, in both these, let's say, slots, 75% of this demand is coming from the industrial sector. And evening, if you observe, there's almost 14% which is coming from the residential sector. So if you can have dedicated and develop specific programs for demand response for these specific category of consumers, we can achieve the benefit in terms of avoiding high cost power purchase. These are the kind of things that a regulator would typically expect from the utility to come up with when they're recommending demand response programs, which gives you a very clear evaluation of what is the cost benefit analysis that you can get. Now this we've done at an hourly level. Our model of course allows to even do 15-minute and half-hour block analysis. This is also, just wanted to share the benefit of, again, demand side management in comparison to EPS is that there is almost a 10 paise reduction in average power purchase cost in 2030, and which results to the saving of almost 17,000 crores. Interestingly, I think from the charts you're also seeing that demand side management is significantly also reducing purchase of high cost power that's above 10 rupees. So for a utility, this makes a case as to why energy efficiency and demand side management programs can really benefit. So finally, I'm just concluding, I think being quick, is without numbers and without sort of cost estimations, it's really difficult to demonstrate the benefits of demand side management. So through this exercise, that's what we've tried to do. And like I said, there are assumptions and there are estimations as well that are built into this model, but these can be refined. These can be also done for longer periods in time. Second, what this model is certainly highlighting is that it can postpone, that we can certainly postpone the need for installation of new thermal generation systems. Because as we reduce demand, and especially demand coming from the different sectors that we are looking at, coal thermal generation can certainly be avoided. Of course, and it gives significant benefits in terms of capital and annual system costs for utilities as well. And it offers a deeper analysis to look into the entire power purchase planning that utilities are currently doing, to look at where and how we are contracting power also for the future. And through some of the cases that we looked at, we are also able to identify specific time periods and specific consumer classes for which demand response programs can also be implemented. I think I will stop there. Thank you. If you have any questions, my email address is there. You can shoot me an email or speak to me. I can take any questions if you have. Yes?
It's just for the curiosity for the 470 crore of saving, what was the investment and what are the interventions required in this?
Yeah, so basically this is the cost that you have to pay for those two, let's say 4-hour blocks.
I'm asking about the intervention in terms of, let's say, we have to buy, let's say, some IoT device, we have to go for some intervention.
Right. So two things. One is essentially you would certainly need to know where this demand is coming from. And like from at least our analysis, we see that most of this is industrial demand. And industries already have AMR numbers. So you know which industries are contributing to demand in those hours. Secondly, the estimation of, let's say, 400-450 crores is coming from in those time blocks where the power is being purchased from and at what cost. So if you offset that power by, let's say, a cheaper source of power, which could be renewable sources, is the benefit that you see. So in terms of additional investment, if you have to ask me, technically there is none at the moment, except for doing this level of analysis to understand in those time blocks where the power purchase is coming.
But the question is how a customer improve the demand response then?
Yeah, of course, the utility has to build a specific demand response program targeted at these consumers, which will give them the benefits. But right now, I think most utilities are struggling with even identifying where and when can demand response programs be implemented. Yes.
Ma'am, when we are approaching any kind of decision-making authority, we certainly face all the question more and more times is that if at all I am doing an energy efficiency program, the spread that I am earning on every unit that I sell should be recovered by this energy efficiency measures, and all the processes that we are also undertaking, like modeling and all, are completely are seemingly so complex that sometimes making them understand how all these results are giving us this figure cannot be put into a perspective of the decision-making authorities. So, what kind of approach can we take in that?
Right. I think this is, what you're mentioning is a very, very valid point. But at least in our experience of interaction with, let's say, decision makers at different levels, there are three things that we need to keep in mind. One, I think, is in terms of the numbers that they understand. So translating our study into their numbers. So even, let's say, today I could have brought in a lot of my modeling numbers and different charts, but it may not be able, I will not be able to convey what I wanted to probably through those complex numbers and figures. So I think that is something that we need to keep in mind. Second, I think, is that entire conviction that we want to do a program itself brings in a lot of impact of what you're presenting to the decision makers. And thirdly, I also think is that there is certainly some level of capacity building that is necessary for these decision makers as well at different levels. And how this will happen, I think Getri is in a better position to get everybody onto a plane. But that is a challenge that most utilities and also other decision makers do face. So yeah.
In that case, I hope this event helps move some more blocks.
I hope you're not targeting me.